So this video, we're going to talk about a bunch of little things. The first one's going to be percent composition. Here is the formula for percent composition. You take the mass of the element over in 1 mole of the compound and put it over the molar mass of the entire compound. And because it's a percent, you multiply by 100. The only tricky thing here is to make sure you multiply by the subscript. So here, there's 2 types of questions you could be asked. One of them is like this, where it says the percent composition of this compound. In that case, you just find the percent composition of each element in the compound. So you're going to need the molar mass of the entire compound. So you find the molar mass of NaHCO3, and that is 84. If you don't remember how to do molar mass, please watch the video from the beginning of this unit. And then all you have to do is take the molar mass of each individual element, multiply it by the subscript in the formula, divide by this number, and multiply by 100. So for Na, we look up on the periodic table, the decimal number is 23. The subscript of Na is 1. Put it over the molar mass of the whole compound, multiply by 100. And then we do the same thing for H. C. And then for oxygen, you do the same thing, but make sure you multiply by the subscript. So this one comes out to 57.1% oxygen. If you're asked this type of question where it has an entire compound, all of these should add up between 99 and 101. Whoops, 101. For this one, it's going to be 99.99% if you add that all up. But because we round them, it should be between 99 and 101. The other type of question you might be asked is this, where they give you a compound and they ask you for just the percent of one element. So for that, you do the exact same thing, but you just have to do it for one element. So here, sulfur, its decimal number is 32. Its subscript is 1. And then you put it over the molar mass of the entire compound. So it asks for one element, but you still want to look at the entire compound for the bottom number. So this one is going to be 98. So that comes out to 32.7% sulfur. Those practice problems we're going to do together in class. The next thing we're going to do in this video is formulas. There are 2 types of formulas. The empirical formula, which is the reduced one, the simplified one, and the molecular formula. The molecular formula says this is exactly how many atoms are in one molecule, so it will often not be reduced. Now, sometimes these are the same, okay? So sometimes your simplified formula is also your molecular formula, and sometimes they're not. So we'll do this practice tomorrow because it's in class because it's just simplifying. What I want to get to is molecular formulas. If you're given the empirical formula, how do you find what the molecular formula is? So you're going to use this thing called N, and then multiply the empirical formula by our N. To find the N, you take the molar mass of the whole compound, which will be given to you, and the molar mass of the empirical formula, which you will calculate. So here, what is the molecular formula of benzene, which has an empirical formula of CH and a molar mass of 78.12 grams per mole? So the first thing you're going to do is find N. N is the molar mass of the compound, which again is given to you in the formula, in the problem, over the molar mass of the empirical formula. So the molar mass of the compound is going to be 78.12. To find the molar mass of the empirical formula, you take this and find the molar mass just like you would. You look up the decimal number of C, multiply it by the subscript of 1, decimal number of H, multiply it by the subscript of 1, and add them together. So that's going to come out to 13. When you do that math, you get 6. So then you take your empirical formula and multiply it by 6. When you do that, whatever your N is, you multiply each subscript by that number. So here, your molecular formula is going to be C6H6. The last thing that's going to be included in this video is 2 of the 3 chemistry laws. For the last one, conservation of mass, we're going to go over that in Unit 4. So we're just going to quickly review the law of multiple proportions and the law of definite proportions. Multiple proportions is the law that tells us we cannot have decimals in a formula or fractions as subscripts. And that's because you can't split up an atom. I mean, you can, but you'll split it up into protons, neutrons, and electrons. You can't have like 1/3 of a carbon atom in your formula because it's no longer going to be a carbon atom. We know that atoms are the smallest units that have the same properties. So the law of multiple proportions is the one that tells us that. The law of definite proportions tells us that no matter how much we have of something, it's going to have the same formula. So water is a good example of this because you've known your whole life that water is H2O. If you have a giant bathtub full of water, it's H2O. If you have a little cup of water, it's H2O. So that does not change. And that's all the law of definite proportions is saying. And then we'll go over some practice